Hello everyone. So based on the task given, our aim is to determine turning points on a function graph and their nature by observing the neighboring gradients about those turning points. So for my part, question 4, the graph is given, which is y equals to negative x squared plus 2x plus 3, and the tangent to the curve at point P. So these are the results. The x coordinates at P are given, which are -1, 0, 1, 2, and 3. To find the gradient of the curve at point P, it is a must to drag the point P. The first part, -1. When I drag the point P to -1, the gradient of the curve at point P is 4. Next, when I drag the point to 0, the gradient of the curve is 2. And when I drag the point to 1, the gradient of the curve is 0. This horizontal line shows that the point P is at maximum point, and this point P also known as the turning point. So when I drag that point to 2, the gradient of the curve is -2. And when I drag that point to 3, the gradient of the point is -4. So based on the results of the gradient of the curve, the sign for dy dx is for -1 and 0 is positive, and at 1, the sign for dy dx is 0, and for 2 and 3, the sign for dy dx is negative. The sketch of the tangents are uphill for -1 and 0, horizontal line for 1, and downhill for 2 and 3. Based on the sketch of the tangent, the sketch of the graph is upside down. The parabola is said to be open downwards. And that is all from me. With that, I thank you.
Hello and a very good evening to everyone. So first of all, the question that given is substitute the values of a, b, and c into the function fx equals to ax squared plus bx plus c to obtain the graph for the curve y equals to x squared plus 2x minus 3. Repeat steps 3 and 4 by substituting the x coordinates from point P in the table with x equals to -3, -2, -1, 0, and +1. So first of all, the thing that we need to do is we need to take the curve y equals to x squared plus 2x minus 3 that given from the question and change it to the formula, which is dy per dx equals to 2x plus 2 after you change it into this formula. And then the second step we're gonna do is we substitute the number, which is the x coordinate given on the question below, -3, -2, -1, 0, and +1. For example, the first number that I substitute in after I getting the formula is -3, which is 2 multiplied with -3 plus 2, we will get -4, and so on with the other question, like -2, -1, 0, and +1. And then after we finish this part, we're gonna need to draw a table and then replace the number from the question 4 with number that given in question 5, which is -3, -2, -1, 0, and +1. After it, we'll need to list down the curve at point P that we got from earlier just now, which is for -3, the gradient of the curve at point P is -4. For -2 is -2. For -1 is 0. For 0 is 2. For +1 is 4. Alright, after we finish this part, we'll need to do the sign for dy per dx, which is a straight line. Because since it's negative, so we must draw a straight line which represents the negative sign, and same goes to this. And here we just need to put 0 since it is it didn't represent anything and it's neutral. And this is positive since number is given is positive. Alright, after we finish this part, we need to go the second last part, which is the sketch of the tangent. So first of all, the sketch of the tangent for both negative number is the line will slightly goes toward the right side like this. For the neutral number 0, it will be just straight line. For the positive number, it will be slightly go to the left hand side. And lastly, for the sketch of the graph, after we got all of this, after we done the top of the part, for the sketch of the graph, we will get a smile face. Alright, that's it for me. I hope you understand. Thank you.
Hi, my name is Nurul Afiqah Natasha Binti Abdullah. Okay, the question is asked to substitute the value of A, B and C to get the curve y equal x cubed plus 4. But before that, we must change the value to the dy over dx, which means it will become 3x squared. How it become 3x squared, which means x cube, we must the cube must minus with 1 and it will be x squared. And where is 3 come from is with it's come from cube, bring it to the front and it will be 3x squared. Okay, how to solve it? Okay, the question already given the x coordinate of P, which is -2, -1, 0, 1 and 2. So after we already changed to formula dy over dx, we just substitute the x, which is x squared, and put the -2, which is x coordinate point of P, into the x here. Okay, we can it sounds dy over dx equals 3 in bracket -2 cube, and we will get 3 will be okay, the 3 will be times with 4 and will be get 12. And you repeat the same steps to the all of x coordinate of P by using the dy over dx 3x squared. Okay, dy over dx equals 3x squared, and substitute the x coordinate of P in the x, and you will get the 12. The answer is 12, 3, 0, 3 and 12. Okay, so the gradient of the curve at point P dy over dx is 12, -2, which is 12, -1, which is 3, 0 and 0, 1, which is 3, 2, which is 12. And the sketch of the tangent will be like this. Okay, in the graph. No, not in the graph, but in tangent. Okay, sketch of the graph will be like S, but not exactly like S. Okay, and the sign of the dx and dy, which is every gradient in of point P, which using dy over dx, which is plus, 0, plus and plus. Okay, that's all.
Hi everyone, today I will present the question number 7 for Roman 1. The question is y equal -x squared plus 2x plus 3. So how to answer this question is dy per dx equal to -2x plus 2 to 0. The answer for x is 1. How I get 1? Because here negative 2 plus 2 will drop. So only left the x as 1. For y, we will insert negative 1 plus 2 plus 3. The answer for y is 4, because negative 1 plus 2 will be 1. So plus 1 plus 3 will be 4. The answer for y is 4. So the coordinate for this question for A is 1, 4. For question B, y equal x squared plus 2x minus 3. We will use dx per dy per dx equal to 2x plus 2 will be 2x plus 1. So the answer for this is x equal to negative 1. To find y, we will insert 1 minus 2 minus 3. The answer will be negative 4. So the coordinate for the question is 1, negative 1, negative 4. For question C, y equal to x squared plus 4. To answer this, we also use dy per dx equal to 2x. So the answer is x is 0. For y, we change here as 0. So the answer for y is 0. The coordinate for the question is 0, 4.
Hello, I'm going to explain question 7, Roman 1, 2, 3, and 4. Take the coordinates of the stationary points. I got 0 and 4. When x increases through the stationary points, how do the values of dy over dx change? When x increases, dy dx also increases. What can you observe on the signs of the gradients for each curve? The sign changes from positive to negative, means like this hand here, this side will be negative, this side will be positive, and x equals to 0. Determine the types of the nature of the stationary points. Stationary point is local minimum, which means the smallest value of the function in the local region. Thank you.